طيب يعطيكم العافية، مساء الخير للجميع. بالنسبة لمحاضرة اليوم، أول محاضرة راح تكون معاكم، وراح نبلش بهذا الفصل إن شاء الله. بلشت معكم الدكتورة غدير سعيفان في البداية، أعطتكم شوية عن الأنتيبيوتكس زي البنسلين، سيفالوسبورينز and other antibiotics. راح أكمل إن شاء الله معكم بباقي المضادات الحيوية، وبعدها راح نكمل في الأنتي كانسر والأنتي فانجل and then anti viral agents إذا لحقنا طبعا. بالنسبه للتوبكس اللي راح اغطيها ان شاء الله راح اغطي تقريبا الامينوغلايكوسايد انتيبايوتكس وراح تكون محاضره، الماكرولايد انتيبايوتكس راح تكون محاضره ايضا، الكوينولون انتيبايوتكس راح تكون محاضره لمحاضرتين، وعندنا التتراسايكلين انتيبايوتكس اللي راح تكون تقريبا محاضره، وعندنا بالنهايه السلفونامايد and other antibiotics. راح تكون بنهايه موضوع الانتيبايوتكس اللي هي اخر جزء. بالنسبه للانتي كانسر ايجنتس هو موضوع كبير، راح ناخذ فيه تقريبا 3 ل 4 اسابيع، وهذا الموضوع راح نشرح فيه بإسهاب موضوع الانتي كانسر. We'll go into some details about anti-cancers, different type of anti-cancers, mechanism of how those anti-cancers work, and we always going to look at the medicinal chemistry point of view of those structures and how they do their anti-cancer activity inside the body. كمان راح نحكي عن الانتي فانجل agents and after we finish the anti-cancer agents, and this will be probably 2 lectures, which means 1 week, and then we'll go into the last topic which is antiviral agents. طيب هلا هاي just a general syllabus can be modified based on the situation، يعني ممكن يتغير هون جزء هناك جزء حسب شو بنراه وبنحتاجه، وبنحاول قدر الامكان يعني نشرح المادة بطريقة مبسطة بوجود سلايدات والوايت بورد. So we're trying to simplify things as much as we can. بالنسبة للعلامات، وبتوقع الدكتورة غدير يمكن مشيت معكم بالبداية بهذا الموضوع. العلامات هي 100 علامة بكل فصل، عندنا 50 علامة للأعمال المنتصف الفصل، اللي من ضمنها راح يكون كويزين بهذا الفصل وميد تيرم اكزام. فراح يكون في فيرست كويز ده يعني الدكتورة غدير أعطتكم إياه، والميد تيرم راح يكون مقسم بيني وبين الدكتورة غدير. تقريبا يعني راح يكون مناصفة، يعني 20 علامة للدكتور غدير و10 علامات إلي، والباقي الكويز الثاني راح يكون كاملا إلي ب10 علامات، والفاينل اكزام راح يكون نحكي تقريبا حوالي 45 علامة مني إلي أو من مادتي، يعني 5 علامات للدكتور غدير. Again, midterm exam could be 15 points or could be 20 points للدكتور غدير 10 إلي. We will see، نشوف نقرر later on قبل ما يتحدد موضوع الميد تيرم اكزام. بالنسبه الماده راح تنعطى عباره عن محاضرتين رسميات، كل محاضره ساعه خلال الاسبوع. هلا بالنسبه للمحاضرتين انا بفضل بصراحه اني to record 2 lectures انزلهم يوم السبت، واترك اخر محاضره خلال الاسبوع اللي بالماده. يعني مثلا اذا كنت شعبه احد ثلاثاء راح تكون محاضره يوم الثلاثاء، اذا كنت شعبه اثنين اربعاء راح يكون في محاضره يوم الاربعاء لايف. فراح يكون في محاضره واحده بالاسبوع لايف، وراح ينزل محاضرتين مسجلات. هلا انا ما عم بزيد اللود عليك كطالب، يعني انا ما بحاول اني ازيد عدد المحاضرات خلال الاسبوع، يعني هو المجموع ان ثيوري راح يكون 3 محاضرات خلال الاسبوع، بس مش هذا الهدف. الهدف انه انا بدل ما اشرح الماده لايف كلها بخلال المحاضره، انا بنزلها ريكوردد ماده الاسبوع، بدل ما يعني اعطيها لايف كل الماده بدون ما انزل اي ريكوردينج. انا بنزلها كلها ريكوردد لماده الاسبوع كامله، ثم بنخلي محاضره للنقاش والدسكشن عشان نشوف شو بيأثر عند الطلاب على هاي الماده. فلذلك يعني هو هاي الهدف من المحاضرات. بالنسبه للمحاضرات الماده انه عندنا محاضرتين راح يكونوا ريكوردد ومحاضره لايف كل اسبوع. بالنسبه لمحاضره اللايف زي ما حكينا هي محاضره للدسكشن اكثر، عشان نجاوب على الأسئلة any issues you need to know about, any problems and so on. And so the live lecture is mainly for discussion، بينما the 2 recorded lectures are the one that covering the material for this week. فagain أنا ما بحاول أزيد المادة، يعني it's the same topic, the same probably load you will have, except that إنه يكون واحدة من المحاضرات live بحيث إنه يكون فيها more discussion. طريقة الكونتاكت if you have any questions you want to ask me you can contact me by email، الإيميل موجود، or you can send me a message على Teams. هلا أنا عملت 5 different teams, one for each section. راح تكون محاضرة اللايف اللي سواء كانت الثلاثاء والأربعاء بنفس وقت محاضرتك، ويراد تلتزم بالمحاضرة لأنه راح آخذ غياب حضور. بالنسبة للتيمز هو الطريقة الأفضل للتواصل، بتحب تبعت مسج هناك ابعته، هو الطريقة الأسرع، أو على الإيميل. يا ريت ما يكون في تواصل على الفيسبوك، لأنه أحيانا بيجيني بالفيسبوك مسجات بحدود 20 30 50 باليوم، فما برد على المسجات بصراحة إذا ما كانت urgent أو ما بتخص يعني إذا بتخص المادة ما راح أجاوب عليها، بفضل تيمز again or email contact. تمام. طيب هلا زي ما حكيت راح ابلش ان شاء الله عفوا اخر جزء اللي راح نحكي عنه اللي هو اليوسفول بوكس والريسورسز. في عندنا 3 بوكس، واحد لباتريك والثاني ل ويلسون اند جيزفولدز، والثالث اللي هو برنسبل ميديسينال كيمستري لويليامز او فوي بسموه اكثر. اللي انا بستخدمه كثير بصراحه فوي which is principles of medicinal chemistry. But the other two you can use them as resources. المادة بفضل دائما تركز على اللي أنا بعطيه بالمحاضرة، اللي أنا بحكيه هو الأساس، وبعدين if you wanna have more information you can go to the book to get more in-depth information if you'd like to. طيب خلينا نبلش بالتوبيك لهاي المحاضرة اللي هو راح يكون عن الأمينوغلايكوسايدز أو أمينوغلايكوسايد antibiotics. طيب لما نحكي aminoglycosides, aminoglycosides is the second most important or the oldest antibiotic that was discovered after penicillin, aminoglycosides, and the main one that was discovered or the oldest one was streptomycin. Okay, streptomycin is the first discovered aminoglycoside antibiotic. It was discovered from a bacteria that's called actinomycetes, or what is known as streptomyces. اللي هم the same thing. These are the same class or the same scientific name for this bacteria, and it's in fact it's a gram-positive bacteria اللي موجودة غالبا دائما بتكون موجودة أكثر بالديرت بالوسخ. يعني لو تطلع على التراب برا وأخذنا مسحة منه راح نلاقي فيه actinomyces or streptomyces. Hello, what the scientists did, they in 1940 there's a specific known scientist اللي هو Waxman or Selman Waxman. هذا الساينتست حكى كان عنده theory دائما إنه we can find remedies for complicated infections، وكان mostly looking for a tuberculosis remedy. كان بيحاول يلاقي علاج للتوبركلوسيس، وكان بهذيك الفترة في عندهم tuberculosis pandemic زي البانديميك اللي بنشوفه بالكوفيد 19. كان بهذيك الفترة عندهم pandemic related to tuberculosis أو السل. فهو كان يحاول to find علاج للبانديميك هو هذيك الفترة اللي هو tuberculosis, and his belief was إنه remedies or the treatments available in your backyard always. يعني بالبيت لو أخذت مسحة من التراب وgrow the bacteria وطلعت منها compounds, you might find compounds that will be able to treat severe infections like tuberculosis. So he discovered from those bacteria that are known as actinomycetes or streptomyces the first discovered aminoglycoside which is called streptomycin. ولاحظ انه اسم الكومباوند هون هو الانتيبيوتيك streptomycin based on this class that's called streptomyces or actinomycetes. تمام. Later he got a Nobel Prize for this discovery of the streptomycin. This is the structure of streptomycin. You will see it's highly polar structure. ليش highly polar structure؟ لأنه we have a lot of hydroxy and amine functionalities. Specifically, amine at physiological pH gets a positive charge. So you'll find multiple cationic state for this structure when it's in that physiological pH. You could have positive 1, you could have positive 2, and so on for that structure at physiological pH. So it's highly polar structure. And that's why we'll see later on if it's not given orally, it's given only parenterally. ليش parenterally only؟ لأنه it's not going to bypass the GI and get absorbed. It's not able to get absorbed through the cell membranes of the GI, and so it's not going to go to the systematic circulation. The only way to get it to systematic circulation عشان ناخذها للبلاد stream إنه to inject it directly into the bloodstream. Sometimes it can be given orally, but in that case it will be used for treatment of GI infection. تمام. It's not going to go to the systematic circulation وما راح تعالج لنا عدوى او انفكشن موجوده جوا البلاد ستريم او في مناطق داخل الجسم اذا اعطيناها اورالي. طيب الامينوغلايكوسايدز as we said these are antibiotics that are active against aerobic gram negative bacilli and staphylococci. هم isolated from gram positive bacteria but they work against gram negative bacteria. وهذا جزء من طبيعة تعايش البكتيريا. البكتيريا أحيانا تفرز some type of chemicals عشان تعيش، بتقتل ال other types of bacteria وتعيش فترة أطول من نوع من الدفاع عن النفس. فهذا ال compounds اللي هم الامينوغلايكوسايد antibiotics واللي main and oldest example اللي حكينا عنه هو streptomycin work against gram negative bacteria in general. They don't work against gram positive bacteria and they don't work against anaerobes in general. So they only work against aerobic gram negative bacteria. Example on this اللي هو E. coli, Klebsiella, Proteus, Pseudomonas aeruginosa, Tobramycin, Gentamicin. These are all examples على aminoglycosides. راح نشوف structures تبعهم a bit later. When they work on mycobacteria, which is one of these most important mycobacteria اللي هي Mycobacterium tuberculosis that causes tuberculosis زي ما حكينا. وهو ال first discovered aminoglycoside streptomycin that works against those mycobacteria, specifically the one that causes tuberculosis, the Mycobacterium tuberculosis. These antibiotics are not active against gram-positive or anaerobic bacteria in general. They're typically used for serious infections وبنعطيهم زي ما حكينا parenterally for parenteral administration and because they're not absorbed orally. تمام. And so they're used for those serious infections because they are compounds that are potent antibacterial agents but they're only given parenterally and they work against specific type of bacteria اللي هم gram-negative aerobic bacilli. They're typically given in diseases or infections, serious infections like infective endocarditis, complicated infections, complicated UTIs, septicemia, osteomyelitis, pneumonia. They are used usually with combination with other penicillin or cephalosporins because of their synergistic activity with those compounds. ليش؟ لأنهم ال other antibiotics اللي هم زي البنسلين والcephalosporin they inhibit the bacterial cell wall synthesis, allowing more of this compound aminoglycoside to go inside to the bacterial cell and kill it in a different mechanism. So these aminoglycosides are used in combination with other antibiotics typically, and as we said, these are bactericidal, so they kill the bacteria. They don't just stop the growth of the bacteria, they kill the bacteria. And also they cause some type of toxicity زي ototoxicity and nephrotoxicity. They're well known to cause auto and nephrotoxicity. What's their mechanism of action specifically? Their mechanism of action specifically, they bind to the 30S ribosomal subunit and they inhibit the protein synthesis inside the bacteria, causing this bacterial cell to die. So they're irreversible inhibitor of protein synthesis and they're bactericidal compounds with the relatively broad spectrum antibiotic activity. All right. طيب how do they get into the bacteria؟ احنا حكينا انهم they're large compounds, they're polar compounds, very polar, so they might have issues to go inside to this bacterial from the cell wall of the bacteria. So how do they go inside? This is how they go. طيب هلا this graph shows here the gram-negative bacteria cell wall which composed of two main parts اللي هو outer membrane والcell membrane أو inner membrane. Outer membrane has porin channel. These are very important for these aminoglycosides, for these polar molecules that will need to go inside to this gram-negative bacteria. And so these aminoglycosides, the first thing, they come here to this outer membrane, they go through the porin channels, which are channels that allow water and polar molecules to go through. So the aminoglycosides will go through the porin, بيدخلوا جوا البورين بوصلوا هاي الاريا, and then they have to go through the second part of this cell wall, which is the cell membrane or the inner membrane. طيب هلا how do they go inside? They are actively transported through the cell membrane into the cytoplasm by an oxygen-dependent process.
so they are actively transported across the cell membrane. طبعا بدل كل امينو جلايكوسايد بيدخل في بروتون بيطلع برا. And so it's important that the area outside where this bacteria is, their pH is neutral. إذا كان ال extracellular pH is low, this makes this process harder to kick the proton out, and this makes this aminoglycoside transport inside harder. طيب شو الأشياء اللي بتساعد على إنه الكومباوند يدخل easier if we use another antibiotic that inhibit the cell wall synthesis? This will have a synergistic effect. And so penicillin can do this, or penicillins can do this. They inhibit the cell wall synthesis. بيخلوا هذا السيل وول أضعف. بيخلوا هاي البروسيس أسهل of aminoglycoside to go inside to the cytoplasm of the bacterial cell wall. So this is how these aminoglycosides go inside the bacterial cell wall. You have to remember كل process إنه aminoglycoside, the large molecules, hydrophilic molecules, very polar molecules. So you need to remember this every time in every aspect of this pharmacokinetic properties of the aminoglycosides. ممتاز.
طيب خلينا نحكي شوي عن الكيمستري اوف aminoglycosides. هلا the most common glycosides that are marketed in the United States اللي هم kanamycin, neomycin, paromomycin, gentamicin, tobramycin and ethylamycin. إذا بنلاحظ إنه كلهم have this suffix of mycin, either mycin أو micin, و some of them they have just اللي هو ال CIN at the end. So this is how you tell if this is an aminoglycoside. طبعا if it's threomycin is something different than aminoglycosides اللي هم usually belongs to macrolide antibiotics. Either way, amikacin is a semi-synthetic derivative of kanamycin A, and it's one of the recent and most recently approved FDA antibiotic. These aminoglycosides are named aminoglycosides because they have amine on a sugar unit, so they are amino sugars, and they are linked glycosidically زيهم زي polysaccharides. تمام؟ but they are multiple sugar units attached to each other, and they typically have an amine group in them. That's why we call them aminoglycosides. كل الامينoglycosides they have what we call an aminohexose unit. Hexose زي مثلا الجلوكوز. So it's a 6 carbon unit sugar with an amine unit on that. So all of them, all aminoglycosides have aminohexose. Some might have pentose, which are lacking amino groups, but the majority of them will have an aminohexose in them. And they are typically 3 rings. The middle rings usually وراح نحكي عنها structure تبعهم. The middle ring or the central ring that we call in the 3 rings contain a highly substituted 1,3-diaminocyclohexane central ring. Again, this is cyclohexane is not really a sugar unit. It's not a typical sugar unit. It has 2 amine groups على position 1 and 3. This is the central ring that all of these aminoglycosides have. So it's a central ring that has 2 other rings attached to it. 2 other rings, they can be aminohexose or they can be pentose rings. طيب شو هي diaminocyclohexane central ring? This can be either deoxystriptamine in kanamycin, neomycin, gentamicin, and tobramycin, or can be streptadine in streptomycin, which is the first discovered aminoglycoside. So the most common one اللي هو streptadine in streptomycin, and then you have this deoxystriptamine in kanamycin, neomycin, gentamicin, and tobramycin. بدي أركز على نقطة مهمة اللي هي فعليا إنه كل الأمينوغلايكوسايدز they have amine on them, so they're highly polar molecules. They dissolve very well in the body of the fluids of the body. They are injected parenterally because of that. They don't go very well to other tissues, say CNS or fat tissues or bone tissues. They are usually concentrated in the body fluids, so they go, for example, in the kidney, in the liver, and they can go to the lung, where you have a lot of fluids. But on tissues that don't have fluids, like bones, like fat, which are non-polar tissue, specifically fat, they don't distribute very well. They all exist on typically بالmarket as a sulfate salt, and that makes them very polar, very easily dissolved. طيب خلينا نشوف شو الستراكشر تبع الديوكسيستريبتامين والستريبتادين. ديوكسيستريبتامين والستريبتادين, as we said, these are cyclohexane. ولما نحكي cyclohexane, typically these cyclohexanes are 6-member ring. As you all know, this is a cyclohexane ring. I'm drawing over here. So this is cyclohexane. Cyclohexane is different than the sugar units, which have one of their carbons will be probably oxygen. These are the sugar units زي الجلوكوز والother hexose. طيب هلا إذا الcyclohexane, as we can see over here, has 6 carbon units, and it's usually has a lot of substitutions on this 6 carbon unit, which is we call as cyclohexane. Typically on position 1 and 3 you have amines, so you have an amine here, and then so you have an amine on position 1, and then you have another amine at position 3 over here, so you have 2 amines, and that's why we call them 1,3-diaminocyclohexane, and then you could have multiple hydroxyls at position 4, 5, and 6. تمام. So let's look at these structures. As we said, اللي هو streptadine is existing in the streptomycin unit, streptomycin aminoglycoside. The streptadine is a 1,3-diamino, so this is position 1 over here, and this is position 3. So you have an amine group, or amine atom at this position اللي هو 1 and 3. But it's not only amine. طبعا there is hydroxy at all other positions 2, 4, 5, and 6. Either way, at 1 and 3 عندنا الامين. الامين هاي substituted even further with it's part of a guanidine moiety. This is called a guanidine. So you have 1,3-diguanidine or diguanidinocyclohexane. تمام. So streptadine is 1,3-diguanidine cyclohexane. Streptamine is a basic unit. The cyclohexane, it's 1,3-diaminocyclohexane. تمام. It's 1,3-diamino cyclohexane. تمام. So it's 1,3-diaminocyclohexane. You can see this is 3 and 1 amines over here, and then you have hydroxy substituting all the other positions. We have 2 deoxystreptamine. Some of a lot of these aminoglycosides that we mentioned earlier in the previous slide have this 2 deoxystreptamine. شو الاختلاف بين deoxystreptamine وstreptamine؟ إنه فقط على 2 position we have 1 oxygen missing or 1 hydroxyl group missing. And then we have this pectinamine, which is very rarely found in those aminoglycosides. It's very similar to those streptamine, except you have an amine, you have a methyl group على الامين, على 1,3 amine. And so these are the main central ring units that we have. We have streptamine or deoxystreptamine, typically deoxystreptamine in the majority of these antibiotics. بينما عندنا streptadine موجود بالstreptomycin. So all of these are the central cyclohexane ring that possibly can be found on those aminoglycosides. Okay. طيب إذا حكينا عن السنترال رينج اللي هي cyclohexane or 1,3-diaminocyclohexane, and this is typically called as ring 2. هاي الجنرال ستراكشر للامينوغلايكوسايد اللي حكينا عنها قبل شوي اللي هي cyclohexane اللي ممكن تكون streptamine, deoxystreptamine, streptadine. كلها هي موجودة بالعادة بتكون هون على this is the central ring that we talk about. This is the cyclohexane ring over here. تمام. This is your cyclohexane ring. Okay. طيب هلا هاي cyclohexane ring إذا and then we have 2 other sugar units attached to it. These are ring 1 as we see over here. This is ring 1 and ring 3. Ring 1 or ring 3, they are typically attached at position number 4 and position number 6 of the central ring, which is the cyclohexane ring. So 4 and 6, 2 positions that you attach on them sugar units on those aminoglycoside structures. On carbon number 4, we have ring 1 attached, and then on carbon number 6, we have ring 2. مهم نعرف انه الترقيم كيف بيتم بهذول الامينوغلايكوسايدز. السنترال ring, which is the cyclohexane, and this is the ring 2, gets the numbering 1, 2, 3, 4, 5, 6. Ring 1, which is attached on carbon number 4, will get the prime 1 prime. So it's 1 prime, 2 prime, 3 prime, 4 prime, 5 prime, and 6 prime لو بدنا نرقمها. لما نحكي عن ring 3 الترقيم تبعها بيكون double prime، يعني 2 برايم على كل رقم راح يجي عشان نعرف انه رينج 3. كيف بعرف انه رينج 2 رينج 1 ورينج 3؟ رينج 1 دائما اتاشت على كاربون نمبر 4 of the central ring which is ring 2، بينما رينج 3 اتاشت على كاربون نمبر 6 which is the carbon number 6 على رينج 2 or the central ring. تمام؟ اوكي. في سؤال انا كل فصل يعني كان ينطرح علي لما كنت اعطي الماده، كيف اعرف انه هدول رقم، انه هاي الكربون رقم 4 ورقم 6؟ هلا مش مطلوب منك تعرف. انا بالعاده لو بدي احكي لك راح اعطيك انه هاي كربون نمبر 4 وهاي كربون نمبر 6. ليه؟ لانه لو رقمت الترقيم بلشت من الواحد هون 2 3 4 راح ما يكون في فرق بين 4 و6 over here and there. So it's hard to tell which one is 4 which one is 6. And so typically كيف احنا عرفناها هنا 4 or 6؟ لانه لما بنطلع على البايوسينثيتيك باثوي كيف هذا الكومباوند تصنع بالبكتيريا، راح نلاقي انه البكتيريا اول شيء بتصنع السايكلوهكسين رينج، تمام، بتكون ما عليها ولا شيء ولا عليها شوجر يونتس، تيجي على كربون نمبر 4 اوفر هير وبتضيف شوجر يونت اللي هي رينج 1، تمام. So that's why we call this as carbon number 4. and then تيجي على carbon number 6 وبتضيف رينج 3 which is why we see over here this is ring 3 attached على carbon number 6. يمكن النقطة هاي ما تكون واضحة، بس إذا في سؤال عليها أو في أي شيء إضافي عليها ممكن نحكي عنها بالمحاضرة اللايف زي ما حكينا. طيب هلا في نقطة مهمة عن الأمينوغلايكوسايدز. A lot of these aminoglycosides they have over time the bacteria developed some type of resistance for them. هلا زي ما حكينا انه majority of these antibiotics used for treatment of aerobic gram-negative bacteria. Some type of bacteria that of a family that we call Enterobacteriaceae, they could develop resistance to this antibiotic, and it's well recognized, well known that these bacteria develop some type of resistance. It's usually hospital-acquired infection with those resistant bacteria for aminoglycoside, which we call as nosocomial infections. These bacteria are usually multi-drug resistant among gram-negative bacilli and can be transmitted to same or different species. So once some of these bacteria develop some type of resistance, they can transfer it to another type of species. They can transfer this resistance to another type of species. And this resistance is usually transferred from one bacterium to another by an extra chromosomal R factor, which is a small circular DNA piece that can self-replicate and transfer by conjugation, by direct contact with other bacteria. And there is a lot of research that was done to improve the resistance to these resistant strains and to understand how these resistance happen in bacteria. And so So the scientists studies the mechanism. How do these extra chromosomal R factors give resistance للبكتيريا؟ كيف بيساعدوا البكتيريا تصير resistant؟ شو البكتيريا بالضبط بتعمل عن هذول antibiotics؟ And they found that the main mechanisms of this resistance including acetylation, phosphorylation, adenylation of these amino hydroxyl groups اللي موجودين بالامينوغلايكوسايدز اللي كنا نحكي عنهم بالسنترال رينج، سواء كانت رينج 2 1 or 3. الامينو hydroxyl groups هذول can be modified chemically by enzymes produced in the bacteria to deactivate the antibiotic or antimicrobial effect of these microbes, of these antibiotics. طيب شو mechanisms that can happen? How do we deactivate these aminoglycosides? We can acetylate the amine groups, we can phosphorylate the hydroxyl groups, or we can adenylate one of these two groups. في سؤال أنا بدي أطلبه منكم as a simple homework to do. Please look online and find how do scientists typically discover these mechanisms of microbial resistance. شو بيعملوا؟ شو type of experiment they do to try to discover how these antibiotics are being weakened by this resistance. So look online and see how that happens. طيب لو نطلع على ال structure of the aminoglycoside and let's to be able to see where those deactivation mechanism work or where these bacteria work to destroy the aminoglycoside antibiotic activity. حكينا احنا في عندنا central ring which is this ring, the cyclohexane or 1,3-diaminocyclohexane if it's a streptamine or deoxystreptamine, or could have a guanidine if it's a streptadine. Either way راح نلاقي هون الامين at 1 position and 3 position. We have other rings اللي حكينا هو عبارة عن ring 1 and ring 2. Ring 1 عفوا and ring 3. We have ring 1 attached at carbon number 4, so this is ring 1, and then at carbon number 6 of this cyclohexane ring we have ring 3 attached. هلا what bacteria can typically do if it has a multi-drug resistance capability or MDR, they can install acetyl or phosphorylate or adenylate these positions of the hydroxy and amine. Acetylation typically happen على الأمين. Acetylation typically happen على الأمين, and we all should know what that means. And if you have an amine group here, let me draw a simple amine group over here. So this is an amine over here. We have an amine, and that amine can be acetylated by installing this اللي هو الأسيتيل from the bacteria. So they can install the acetyl over it. Installation of the acetyl will deactivate, راح ترد. It will destroy الأمين properties. It will destroy الأمين. الأمين لما يكون جزء من acetyl اللي هو راح يكون جزء من amide functionality over here. It has different physicochemical properties than the amine. It's not charged or doesn't have a positive charge at physiological pH. It's not basic anymore. So that's a destruction of the physicochemical property of that amine. And that means this aminoglycoside will not be able to bind to its target, which is the 30S ribosomal subunit that's needed for protein synthesis of these bacteria. So this is one of the ways that this bacteria destroys aminoglycosides by acetylating the amines over here, for example, at the position at the ring 1, ring 2, or 3, or they can phosphorylate. And phosphorylation typically happens على hydroxyl. Phosphorylation only happens على hydroxyl and can only happen on the 3' position, which is the hydroxyl اللي موجودة على 3 position in ring 1. So this can be acetylation or phosphorylation. And the last option for these bacteria, they could also adenylate. They can add an adenyl group, which is a nucleotide, on these positions to destroy the activity of these aminoglycosides. بالعادة أي تغيير على هذول الهيدروكسيلز والأمينز will change the structure activity relationship of those compounds of aminoglycosides and will destroy the antimicrobial activity of these compounds. So this is how these microbes do modify the aminoglycosides and destroy their antimicrobial activity. طيب خلينا نحكي عن structure activity relationship لكل من الرينجز اللي موجودين اللي هم 3 رينجز بالامينوغلايكوسايدز. بدنا نحكي specifically عن each ring لحالها ونحكي عن structure activity relationship of these. نبلش بأول رينج اللي هي ring 1, and ring 1 is the one that's attached to the position 4 the central ring or ring 2. So in ring 1 we have multiple positions that are important for activity, and we have some that are not very important for activity. But in general, ring 1 is very important for the broad spectrum antibacterial activity of these aminoglycosides. Ring 1, as we know, it will be numbered as 1 prime. This is 1 prime carbon, 2 prime, 3 prime, 4 prime, 5 prime, and 6 prime. The primary target for antibacterial or for the bacterial inactivating enzyme اللي بيعمل destruction للactivity of aminoglycosides اللي هي ring 1 على فكرة. This is the most susceptible ring for this inactivating enzymes that are produced by the multi-drug resistance bacteria, specifically Enterobacterius. تمام؟ طيب هلا إذا ring 1 is very important for broad spectrum activity and it's the target for this inactivating enzyme. طيب خلينا نطلع على different locational positions. We know that there is an amine functionality typically at position number 2 and position number 6. They could be either an amine or hydroxy, but they're most of the time they're amines rather than hydroxy. هلا الkanamycin is one of those aminoglycosides that have either amine or hydroxy at position 2 prime and 6 prime. Kanamycin A has amine at this 6 prime بينما عنده hydroxy على 2 prime. الkanamycin B عنده amine على both 2 prime 6 prime. Kanamycin C has at the 6 prime hydroxy while have at amine at 2 prime. Remember إنه multi-drug resistance bacteria able to do either acetylation على الأمين or phosphorylation على الهيدروكسي. وده بتتذكر من السلايد السابق اللي حكيناه إنه الacetylation happen typically على الأمين بينما الphosphorylation usually happens على الهيدروكسي. طيب هلا الشيء المهم نعرفه انه ال 3 وال 4 prime او 3 prime and 4 prime location they have hydroxy in all of these antibiotics اللي هم الكاناميسين A, B and C. As we said earlier, الكاناميسين location 3 specifically is very prone يعني susceptible for phosphorylation by inactivating enzyme. بس لقوا انه في كثير aminoglycosides موجودين زي الجنتاميسين وزي النيوميسين. These are all aminoglycosides that lack these 3 prime hydroxy or 4 prime hydroxy. And so basically these hydroxys are not important for activity. You can have active aminoglycoside without the need for those hydroxys at the 3 prime or 4 prime. An example on this اللي هو الجنتاميسين that lacks these 2 hydroxys. وكمان عندنا in other ones زي النيتيليمايسين and so on. هلا رح نحكي عنهم a little bit in the next slide. But it's important to note that the hydroxys at the 3 prime and 4 prime are not important for the activity, and so this is very important to know. So they're not important for the biological activity to produce the biological activity, but if you do any phosphorylation عليهم راح ينزل activity. فالأفضل we don't have them. If we remove them, we produce an antibiotic that will not be as prone or as susceptible to drug resistance, and it will be still active. اوكي خلينا نطلع اذا على examples زي ما حكينا اللي هو tobramycin is an example على aminoglycoside that doesn't have the 3 prime oxygen. So it's a 3 prime deoxykanamycin B. It's missing the oxygen and it's still active. tobramycin مستخدم كثير بالبرودكتس بالفارماسيوتيكال برودكتس وعندنا بالصيدليات موجود as part of the Topradix as you all know. This is the commercial name. Gentamicin is another example على drug of those aminoglycosides that doesn't have the oxygens at 3 prime and 4 prime. So it's dideoxy. It's missing both oxygens at 3 prime and 4 prime and still active. In fact, it's better for not having those hydroxys to make it less susceptible for the enzymes that do phosphorylation على هذول hydroxys that are produced by some of those enterobacteriaceae. In addition, عندنا كمان إن telemycin does not have the 3 prime and 4 prime. طبعا they have other differences. We don't want to talk about them at this stage. But either way, so it's important to know that the ring 1 is very important for activity, for the broad spectrum activity. But we don't need these 3 prime and 4 prime. In fact, it's better not to have them زي ما هو بحالة التبراميسين والجنتاميسين. تمام؟ location at 2 prime and 6 prime they're typically amines, specifically بحالة الكاناميسين B مثلا, both are amines. And so these 2 prime and 6 prime these 2 prime and 6 primes amines are part of kanamycin B. هلا برجع باكد بس على نقطة 3 prime 4 prime. هاي 2 hydroxys اللي هون مش مهمين. example اللي هو الجنتاميسين ونيتيليمايسين عندنا دبل بوند between 3 prime and 4 prime. طيب الجنتاميسين كمان في شغلة مهمة فعليا اللي هو it has a methyl at the 6 prime هون. وحكينا انه هاي الامين is prone for acetylation. الامين هاي prone for acetylation by those inactivating enzymes. So one of the ways to prevent this acetylation انه اخلي الامين bulky either directly على الامين or على الكربون next to the amine. And this is what gentamicin is basically has. Gentamicin فعليا as an antibiotic was found if you add a methyl over here on this 6 prime, this will reduce bacterial resistance because it prevents the acetylation على الامين. So gentamicin في شغلات مميزة جدا نعرفها اللي هو 3 prime 4 prime do not exist. 2 hydroxys فما بصير فيهم phosphorylation على هاي النقاط. كمان الجنتاميسين عنده على 6 برايم على الكربون specifically في ميثيل جروب هون محطوطة وهاي الميثيل جروب راح تعمل bulk area around this amine بتعمل steric hindrance بنسميها هذا الكونسبت المفروض الجميع يعرفه من organic chemistry. This prevent acetylation على الامين from inactivating enzymes. So these are important things that exist in gentamicin. تمام اللي هو عندنا 3 prime 4 prime are missing ما في hydroxys. And then we have 6 prime also a methyl there that prevent acetylation على الأمين. In other antibiotics you can also methylate الأمين نفسها as well and then end up with active compound that does not get affected by inactivating enzyme. So عشان نلخص ring 1 أهمية ring 1 مهم لل broad spectrum activity. 3 prime 4 prime position hydroxys are not necessary for activity. In fact, removing them will make the compound stronger against this resistance or better activity against this resistance bacteria. 6 prime amine can be methylated directly amine أو الكربون تبعت 6 prime, and this example and on this اللي هو gentamicin. This will enhance antimicrobial activity against drug resistance bacteria زي الانتيروبكتيريا اللي عندهم inactivating enzyme. تمام. Alright, so let's talk about ring 2. طيب what about ring 2 in the aminoglycosides اللي هي central ring اللي حكينا عنها. هي عبارة عن cyclohexane ring with modifications أو substitutions على different carbons. حكينا it's 1,3-diaminocyclohexane ring. This is called the ring 2 or the central ring. حكينا also it could be streptamine, deoxystreptamine or streptadine زي ما ذكرنا سابقا. هلا الرينج 2 مش زي رينج 1، يعني بتقدر تعمل عليها أقل modifications ومش سهل تعمل عليها modification to end up with active compound. So it's less there is less chance for modification to produce more potent antibiotic. For example, one of the examples that are successful على modification اللي هو acetylation or acylation. It's not acetylation, it's an acylation of this amine at carbon number 1 with what we call as hydroxyl aminobutyric acid. This is the moiety اللي اسمها hydroxyl aminobutyric acid or abbreviated as HAPA. هاي group in this case when was added to the amine at position number 1, it protected the aminoglycosides from the process of acetylation of the inactivating enzymes. يعني inactivating enzymes لما كانوا يجوا يعملوا هنا acetylation على الامين اللي على كربون نمبر 1 بالامينوغلايكوسايدز. لما ضفنا عليها الهابا هون هذا الحكي بمنع الاسيتيليشن. مش بس هيك، كمان لقوا انه فعليا اضافه هاي الجروب بتمنع other inactivating enzyme from binding to the aminoglycosides and prevent other deactivation on other groups, functional groups الموجوده بالرينج 2 والرينج 1 ورينج 3 كمان. تمام. فهاي الهابا as we can see this group offers some protection for these antibiotics to make them resistant for those inactivating enzymes. وبنلاحظ انه هون وجود الامين، فاحنا فعليا هون كان عندنا امين ضل حطينا امين موجود هون، بس هاي الامين ما بتعرف عليها الاسيتيليتنج انزيمز لانها مش جزء من this cyclohexane ring and it still keeps this pharmacokinetic properties and physicochemical properties by preserving this amine in this position فعليا قريب من position number 1. So again this HAPA addition of HAPA acylation. لما نحكي كلمة acylation يعني addition of acyl group. acyl group هي مش الاسيتيل، هي any type of carboxylic acid group that was bound to amine in an amide functionality. So this is one of the main modification that was done على ring 2 اللي هي فعليا فقط على position number 1 الامين was acylated with HAPA to prevent enzymatic inactivation, and this resulted in an improved activity of derivatives against resistant bacteria. اللي بدي احكي كمان عنه اللي هو النيتيليمايسين. النيتيليمايسين is a similar structure to amikacin. amikacin زي ما حكينا هو عبارة عن semi-synthetic compound of kanamycin A with this new HAPA functional groups added على الامين of carbon number 1. So this is the amikacin. تمام. النيتيليمايسين similar. انا راح اطلب منكم انتم تدوروا لي شو النيتيليمايسين وشو الستراكشر تبع النيتيليمايسين and what modification was done to improve the biological activity of nitromycin. طيب نحكي عن اخر رينج اللي هي رينج 3 والرينج الاخيره اللي بالستراكشر تبع الامينوغلايكوسايد. رينج 3 حكينا can be either 6 carbon unit hexose or pentose. تمام. hexose or pentose. هلا هاي الرينج يعني you can do many modifications on it and keeping the biological activity similar or even better than the original compound. فبنقدرش نعمل عليها، بنقدر نعمل عليها كثير موديفيكيشن مش زي الرينج 2 اللي ما بنقدر نعمل عليها. الرينج 2 كان اصعب نعمل عليها موديفيكيشن فقط على كربون نمبر 1 الامين قدرنا نعمل عليها acylation. برينج 3 you can do a lot of modifications. ورينج 3 can be either 6 carbon unit بنسميها hexose or pyranose. Pyranose means a 6 carbon sugar unit, or can be 5 units. In this case we call it pentose sugar unit which has 5 carbon unit. راح نشوف examples later on لما نحكي عن neomycin وparomomycin. بس خلينا نحكي عن الجنتاميسين. Gentamicin is an example where your ring 3 is a 6 carbon sugar unit. It's pyranose. طيب لو بدنا نحكي عن 6 كربون طبعا حكينا او الرينج 3 لما حكينا بنرقمها بنحط عليها دبل برايم 2 برايمز. فهاي كربون نمبر 1 دبل برايم 2 دبل برايم 3 دبل برايم 4 دبل برايم 5 دبل برايم and so on. تمام. طيب
هلا خلينا نحكي عنهم position. على 2 double prime الامينو derivative زي example عليهم السيلدومايسين are highly active. So at 2 double prime at carbon number 2 in the ring 3 you can add an amine. This will make the compound more active, more potent. At carbon number 3, which is the 3 double prime position, you can have primary or secondary amine. This amine can be primary or secondary, it doesn't matter. In both cases it's active. So you see there is a lot of changes you can do at ring 3. And in addition to that, ring number 4, high hydroxy can be either an axial or equatorial position. In case of gentamicin, this is an axial location, that hydroxy. Tamam? And this axial is better for the compound to be resistant for those inactivating enzyme that bacteria produce. يعني بيحافظ على الكومباوند من انه يتحطم بالinactivating enzyme, لانه الاكسيال بوزيشن لما الهيدروكسي تكون على الاكسيال بوزيشن بيكون اصعب يصير عليها deactivation, اصعب نعملها phosphorylation or adenylation. تمام؟ فذات helps in protection of this compound from inactivating enzyme. طيب هلا ال 6 position 6 also there are some modifications that resulted in better antibacterial activity, بس ما بيهمني تعرف 2 3 and 4. ال other examples حكينا زي neomycin and paromomycin. These are two natural products of aminoglycoside, يعني ماخوذين من البكتيريا directly, and they were found to have 5 carbon sugar unit, which is pentose, or we call it as furanose لأنها furan ring. So it's a furanose. And you can see these are the two examples, these are the two structures of neomycin. And you can see this is neomycin, this is the ring 3 over here. لاحظ إنه ring 3 مرتبطة على carbon number 5 بالcentral ring أو ring 2. So this 5 carbon sugar, which is furanose ring, you can see is also substituted with a 4th sugar unit. So this ring 3 can have modification, further modification by additional carbon unit, a sugar unit added to this ring, and this will keep still the activity of those compounds. In general, they found that when you have a 4th ring, لما يكون عندك 5 carbon units زي الفيورانوز، لما نضيف عليها 4th ring نضيف عليها كمان sugar unit, this enhanced the biopotency or enhanced the antimicrobial activity. So that's beneficial. So اللي بدي تعرفوا من هذا السلايد انه فعليا في examples. Our ring 3 is a 5 carbon sugar unit, which we call furanose or pentose, and an example of those اللي هم neomycin, paromomycin. Both of those are natural products. الثيرد ring لما تكون pentose لما تكون furanose نقدر نضيف عليها 4th ring, and this will enhance the activity. 4th sugar ring will enhance the biopotency and the activity. طيب هذا كل اللي بيهمنا نعرفه عن الامينوغلايكوسايدز in general, and this is what we want to talk about today for the aminoglycosides. حكينا عن structure activity relationship, حكينا شو أهمية الرينجز 1 و 2 و 3, حكينا كل لوكيشن بهاي الرينج كيف مهم بيأثر على الاكتيفيتي، حكينا وين اللوكيشنز اللي بالرينجز اللي ممكن يصير عليهم specific enzymatic inactivation by resistant bacteria، وحكينا ان جنرال عن البيولوجيكال اكتيفيتي في امينوغلايكوسايدز. هيك بنكون هنا كامل التوبيك تبع الامينوغلايكوسايدز لهي المحاضره. اذا في اسئله اكيد بنحكي باللايف، ويعطيكم الف عافيه.